In this lesson, I'm going to introduce you to systems of equations, but Algebra 2 level. So just a quick reminder, in Algebra 1, you learned about systems of equations where two lines intersect, and that intersection point was one solution. And it was written as x comma y. So this was a 2 by 2 system of equations because you had two variables, x and y, and then two equations which created two lines. What could also happen when you graph two lines was two lines that were parallel. In this case, it was a no solution scenario. They will never meet. And then they had third scenario where two lines were exactly in the same place at the same time. And these are coincident lines. So this is when they had infinite amount of solutions. And in Algebra 2, we're going to have something similar happen, but instead of lines, we're going to have planes. So these planes are created because we have three variables. We have the x, the y, and the z. Each one creates a plane, just like x and y created the coordinate plane. Here we have like a three-dimensional plane. So a 3 by 3 system is when you have three linear equations and they have three variables each. Okay, and then one solution will be where all these three planes meet at the same time. So when they have a common point. If you look at this picture, this middle point is where they all have that common point. They all meet at the same time in the same place. So we call that the solution, the one solution. So these points are going to be called order. So just like an order pair, these are going to be order triples. So again, this is called an order pair because there's only two. So now we're going to have order triples. And they're going to be written as x, y, and z. Just like x and y, but now we have x and y and z. And whenever you find a solution using whatever method, you just got to make sure you finalize your answer by writing it in this format. You can as well have a scenario where you have no solution, which means that the planes are never touching, which is shown in this first picture. These are three planes not intersecting at all. And the second picture shows that two planes intersect right here, and then two planes intersect right here, but the three planes are not intersecting at the same time. The third example shows how it creates like a triangle, but each corner is like two planes only intersecting. So that's not three. We want all three to be intersecting in one point. So even if they were all to meet, like in this example at the same time, then this is not going to be one solution. This is actually going to be one infinite solution scenario because you have a point of intersection there and then another point and then another point. So all of these are points of intersections. And just like in Algebra 1, when you have so many solutions, they create that infinite amount of solutions. So when all three planes meet and create that line, that's when you will have infinite solutions. You do not need to memorize these images, but it's just for you to understand that whenever you calculate the answers and you get any of these are the visual representations of what happens in each scenario. This second picture, I just want to explain that it's actually two planes in here. That's why it looks a little thick. They're coinciding planes. They're in the same place, same time. And then this third one is meeting them. So they're still creating that infinite amount of solutions. And then this last image, this is the three planes all coinciding. So they're all together in the same position, same place at the same time. So this is an infinite amount of solutions everywhere. In the back of the paper, you have the next part. This is just showing that anytime you have a solution or you're given a solution, you can check if that solution is really a solution for the system or not. So whenever you have three values given to you, just label them x, y, and z because they're always going to be in that order, the order triple. And to check if it is a solution, you have to substitute these values into the variables for each equation. In order for it to be a solution to the system, it has to check for all three. It has to be true for all three equations. So let's check. The first one has 2x, so we're going to replace the x with 4 according to our values up here. So we're going to have 2x, so 2 times 4, and then minus y, so we're going to put minus -1, plus z, so we're going to put plus -5. I strongly encourage you to write parentheses every time you substitute because it decreases the chances of you making a mistake. At this point, you can either solve this following PEMDAS in your mind or on paper, or you can use your calculator as well if needed. So for example, 2 times 4, that will be 8, negative times negative, that's +1, and then positive times negative will be -5. So 8 plus 1 is 9, 9 minus 5, that does give you 4. So the first example checks. Let's check the next equation. So we have x, so that's 4, plus 3y, so 3 times -1, minus 2z, so 2 times -5. And then this should equal 11. So let's check. 4, and then 3 times -1, that's -3. Negative times negative is positive. 2 times 5 is 10. So then 4 minus 3 is 1. 1 plus 10 is 11. So that checks as well. Let's try the third one. So we have -x, so -4, minus 2 times -1, minus 4 times -5. And this should equal to 13. So let's check. Negative times positive will be -4. Negative times negative, that's +2. And negative times negative is positive. 4 times 5 is 20. So the -4 plus 2 is going to give you -2 plus 20. And that is not going to give you 13. That is going to give you 18. So 18 is not what you have right here. So that means this doesn't work for the third equation. So to summarize, your solution that is given right here at the top, this is not a solution because it doesn't work for the third equation. It has to work for each equation in order for it to be true, to be a true solution. So now let's try the next one. So we're going to replace these 3 letters, x, y, z, on each variable for the equations. Now notice the third equation only has 2 variables. This is okay. The y is technically still there, but it's written as 0y. So they just don't put it because 0y is 0 times a number, and that just means it becomes 0. So it disappears. So anytime you're missing a variable, the coefficient for that variable was probably 0, and that's why it's not there. So let's check real quick. So we have 1 plus 2 plus 3. So 1 plus 2 is 3. 3 plus 3 is 6. So that first one checks. And now we have 2 times 1 minus 2 plus 3. So 2 times 1 is 2 minus 2 plus 3. 2 minus 2 is 0. And 0 plus 3 is 3. So that checks as well. Let's try the last one. So we have 3 times 1. And be very careful here. You got to make sure you put the correct value for the variables that you're given. So x is 1, and then minus z. Z is 3. So this 3 times 1 is 3. And then 3 minus 3 does equal 0. So it checks. So because this solution does apply to all 3 equations, this is a solution to the system. I hope this video helps you in understanding this topic so far.